In this video, we are continuing our Quiz 1 review and are going to do a practice problem involving 3 overlapping sets. So the example says, suppose that the number of elements in A intersect B equals 4 times the number of elements in A intersected with B intersected with C. The second condition is the number of elements in A intersected with B is equal to the number of elements in B intersected with C. And that also equals the number of elements in C intersected with A. The third condition is the number of elements in B is 249. Fourth condition is the number of elements in A union B is 407. And the last condition is the number of elements in A intersected with B complement intersected with C complement is 125. It then says find the number of elements in exactly 2 of A, B, and C. So I want to begin by giving you all the opportunity to try this question first. So pause the video for about 6 minutes to try this on your own first. 4, 3, 2, 1. Pause the video. Pause it for 6 minutes to try this on your own. Alright, so hopefully you've done that. Hopefully you paused it for 6 minutes to try this on your own first. So I want to begin, as we usually do in questions like this, by drawing a Venn diagram. So this question has an A, a B, and a C. So I'm going to draw 3 circles. So 1 for A, 1 for B, 1 for C, and then a universal set. So I'll draw a rectangle all around this. So I'll call that U. And like we normally do, I'm going to work inside out in our Venn diagram. So if I focus on the innermost region, the portion of this Venn diagram that is the overlap of all 3 circles, the question doesn't tell me how many elements are in the intersection of A and B and C. The first condition tells me a little bit of information about the intersection of A and B and C, but it just tells me how that's related to the number of elements in the intersection of A and B. So because I don't know exactly how many elements are in that intersection, and that's usually our starting place, I'm going to assign a variable to that. I'll let x be the number of elements in A intersect B intersect C. So I'll label an x in that region. And then next, I'll start to focus on some of these regions that are part of the intersection of 2 of the circles. So the intersection of A and B, or the intersection of A and C. So what I'm going to do, thinking about the first condition still, the first condition tells me something about A intersect B, and how the number of elements there are related to the number of elements that are in all 3 circles. And it tells me that, well, the number of elements in A intersect B is equal to 4 times the number of elements in A intersect B intersect C. And actually, just to make my ends look a little bit different than intersection symbols, I'm going to start to write them like 4 and put a little curly thing here and then N. So I'm going to do the same thing with this N. I'll put a little curly thing and then N, just so it looks a little bit more different than just an intersection symbol. So let's make my N look a little different. Okay, and so this is 4 times, and I'm calling the number of elements in A intersect B intersect C x. So I don't know how many elements are in this region, so maybe I'll pick a variable here like A. But at this point, I do know that if I add up the x and the A, if I add x to A, that gives me the total number of elements in the intersection of A and B, which we just said should be 4x. And if we rearrange this to isolate A, we get that A equals 4x minus x, which is 3x. So that's what A is equal to. A should be 3x. All right. So based off of the second condition tells me that the intersection of A and B should have the same number of elements as the intersection of B and C, and that should have the same number of elements as the intersection of C and A. So if I write that down, since the number of elements in A intersect B equals the number of elements in B intersect C equals the number of elements in C intersect A, the other sections where two sets overlap must also contain 3x elements. So there's also got to be a 3x here and a 3x here. All right, so now if I go to the next condition that the problem tells me, it tells me that the number of elements in B is 249. So if I think about the set B, there's one missing portion of that, which I don't know. So I'm going to put a variable there like y. And if I use what this condition told us, that the number of elements in B is equal to 249, then when we add up all the portions of that, so I see a 3x in there, I see an x, I see another 3x, and then I see this y, this new variable that we just assigned for this missing part of it, well, that should add up to 249. And simplifying this, 3x plus x plus 3x, that is 7x. So we get 7x plus y equals 249. Okay, so we have an equation with two variables. Usually to be able to solve for two variables, we need a second equation. So maybe one of our other conditions will give us that. So I'm actually going to jump to the last condition at this point, because this tells us very specific information. So this is A intersect B complement intersect C complement. So that means we're talking about stuff that is in A, but not in B, because that's B complement, and not in C, because that's what C complement is referring to, not in C. So what's the section of this Venn diagram that's in A, but not in B, and also not in C? Well, that is this part over here. This is where the 125 is going to be. So we actually know specifically where the 125 is. It's the part of A that lies outside of B and outside of C. Okay, so that's nice. We got the last condition. And now let's focus on this fourth condition. The number of elements in the union of A and B should be 407. So I'm going to write that down. Let me zoom it out a little bit more. And then write down that the number of elements in the union of A and B should be 407, because if I add up all the parts of the union, well, I see 125. I see a 3x. In fact, I see three 3x's, plus a 3x, plus a 3x. I see an x. And then I see that plus y. So that should be equal to 407, the problem told me. And if I simplify this, 3x plus 3x plus 3x plus x, that is 10x. And then I get that plus y. And that's going to be equal to 407 minus 125, if we subtract the 125 over it, which gives us 282. So at this point, we do have two equations and two variables. Here's equation 1, and here's equation 2. So we have to put on our algebra hat and remember, well, how do we solve? Remember, this is called a system of equations when we have multiple equations and multiple variables that we want to solve. So one of the ways that we can do that is by doing what's called elimination. Elimination was all about maybe you add the equations together or subtract them, or maybe you multiply one of the equations by a number and add it to the other one or subtract it from the other one. But the whole point of elimination was we try to do something to the two equations to eliminate one of the variables. And I can eliminate one of them if I subtract the two equations. So for example, if I do the second equation minus the first equation, and I do that subtraction on both sides, on the left-hand side, I'm going to write the left-hand side of equation 2, which is 10x plus y, and subtract the left-hand side of equation 1, 7x plus y, and do the same thing on the right-hand sides. Take the right-hand side of equation 2, which is 282, and subtract the right-hand side of equation 1, which is 249. So, okay, on the left, If I distribute this negative sign, I get 10x plus y minus 7x minus y equals 282 minus 249. That's 33. So now the plus y and the minus y cancel. So we get 3x equals 33. And if I divide by 3, we get x equals 33 over 3, which is 11. So awesome. We know what x is at this point. But remember, the question wanted us to find the number of elements that are in exactly 2 of A, B, and C. So exactly 2 of the sets. So what portions of this Venn diagram correspond to the region that I want in exactly 2 of the sets? Well, it's here, and here, and here. Each of those regions is in exactly 2 of the sets. So I got to add up 3x plus 3x plus 3x. All right, so let's do that. So the number of elements in exactly 2 of the sets is 3x plus 3x plus 3x, which is 9x. And if I plug in 11 for the x, we get 9 times 11, which is 99. And that's our answer. So coming back to our goals for this section on doing some quiz 1 review and practice problems, we finished our one goal, which was to do practice problems to help us prepare for that quiz. And remember, like I mentioned in the overview video, because on quizzes, I'm assessing your ability to apply stuff that we've learned to solve new problems, I really recommend that you spend the majority of your study time, at least 70%, actually trying practice problems. So from our worksheets that I post on Camino and from the optional homework problems.